This is Unit 5, Periodic Table, Lesson 3, Trends in Atomic Radius. How can we predict changes in atomic radius using the periodic table? By the end of this lesson, you will be able to describe the trend in atomic radius, and you'll be able to explain why the trend in atomic radius exists, and you will be able to compare the radius of atoms to ions in metals and nonmetals. Do now. So atomic radius is the size of the atom, and you can find these values on table S. So if you look on table S, you'll see the very last column on the right is the atomic radius in picometers. So you'll have to look at the tables on the front of your reference table to determine how much smaller than a picometer is. And the radius is measured from the center of the atom to its edge. The trend in atomic radius is this. As we go across a period, the trend is it decreases. The reason why is because the nuclei have a greater nuclear pull, a larger positive charge, which pulls those electrons closer. So the radius decreases as I go from left to right because I have more electrons but the same number of electron shells. I have more protons with the same number of electron shells, and therefore those greater positive pull is going to pull those electrons in. So here's a visual representation. The atomic radius of aluminum is 124 picometers. There are 13 positive protons and 3 electron shells. Chlorine's radius is 100 picometers, which is smaller than 124 because there are more protons in the nucleus, however the same number of electron shells, so they get pulled in tighter. So we can also compare lithium and fluorine in the same rationale. 3 has less pull than 9 on those negative electrons. Down a group, the trend is the radius increases. Why? Because the greater number of energy shells indicated by the period number is increasing. So period 1, period 2, period 3, etc. As I increase that period number, I'm increasing the electron shells. So here's period 2, 1, 2 shells. Period 3, 1, 2, 3 shells. Period 4, 1, 2, 3, 4 shells. So as I increase those electron numbers, I'm increasing the radius. So here's another visual representation of the trends in atomic radius. As I go down the group, my radius increases. As I go across the period from left to right, my radius decreases. So why? The atomic radius decreases across a period proton pull. Across a period, there are more protons with a greater nuclear pull. The atomic radius increases down a group because there are more electron shells. So using table S to determine the trends in atomic radius, if you can't remember the trend, you'll just look it up on table S. So to figure it out, pick a period or row or group or column and note the values of the elements. So all you're going to do, if I go across a period, what is the trend in atomic radius? So 1, pick an element on the left side of the periodic table, and then pick an element on the other element, another element on the right side of the same period. So lithium and fluorine are both in period 2. One's on the left, one's on the right. I'm going to go to table S, and I'm going to find those 2 elements. So lithium has 130 picomolar. It's on the far left. And fluorine, it's boxed in here, has 60 picomolar, which is smaller than 130. Therefore, my trend is decreasing. Recall ion size in metals. When an ion radius is smaller than the atomic radius because metals lose electrons to form cations. So for example, a sodium atom, when I lose 1 electron, I've now decreased the electron shells by 1. Therefore, I'm getting a smaller atom, a smaller ion, and that trend is true for all cations. For nonmetals, the ion radius is larger because I'm gaining an electron to form an anion. So for example, with chlorine, I have a 7 valence electrons. When I gain 1 electron, I have now added more to that shell, causing the nuclear pull to be less, and I will have a larger ion compared to its atom. So here is a visual representation. For anything that becomes a positive ion, those positive ions will be smaller than the atoms, and anything that becomes a negative ion, those negative ions will be larger than their atoms. So check your understanding. And now you are able to describe the trend in atomic radius, explain why that trend in atomic radius exists, and compare the radius of atoms to ions in metals and nonmetals.